At this point, ANSYS knows the governing equations that we want to solve and the domain over which we want to solve it. So let's go ahead and specify the boundary conditions at the edges of the domain. If I go back to my slide on domain and boundary conditions, we saw that there were two fundamentally different kinds of boundary conditions. You could have boundary conditions on the displacements or on the stresses. And you could actually have a mixture of the two. We won't get into that over here. And I also noticed in this figure that my z is in opposite direction to that z. So this is a coordinate system I will use. Let's start by specifying the displacements at the left face that is attached to, say, a wall. So I will go to mechanical. I will highlight static structural in the tree, and before I select supports, let me kind of manipulate the view. So I want the z to be in this direction. So if I hold down the middle mouse button, and I can manipulate the view, and then if I hold down the control key, and I can translate using the middle mouse button. Okay, so get to kind of a view like that, maybe, and say supports, fixed support. Okay, and then, okay, where do you want to apply the fixed support? So if I go here, it seems to be highlighting the back face. So if I select that, it says, oh, there are two faces, and in that view, and the second face seems to be, the first face is the lateral surface. I don't want that. The second face is actually the inside one. That's not what I want. So let me zoom in here a little bit and select that. Okay, now it has that back face, or I could check that by just manipulating the view. Or I could have just manipulated, into this view and clicked on that. There are multiple ways to do it, but I just wanted to show you how this can be useful. And I'll say apply. Okay. And let me rename that to remind myself that what I'm really doing, and students forget this, is I'm specifying u equals v equals w equals 0. Okay. 3 displacement boundary conditions, a 3D problem. Then if I go back to my slide, at the free surfaces, and actually there are two free surfaces. I think in an earlier slide, earlier video, I mentioned only the outer free surface, but there's also an inner free surface, the lateral surface, and there the appropriate components of the stresses have to be set to 0. And free surface is the default in ANSYS, so it'll do that. So we don't need to do anything on that surface, and also on that inner lateral surface, because the defaults will apply. What about the boundary condition at this face? So if I go back here, I can specify 4 points on the surface, and I would have to go back to space claim for that and put forces at those 4 points to get that equivalent moment. Instead, what I'm going to do is ANSYS has this condition, where you can apply a moment, and essentially it will distribute forces along that face to get that moment. And so to get that moment, what I did was, so if I go to pens, so to get the moment that on that face, so if I look at that force, the moment due to that is F times the moment arm. Let's say that's R times F, and I assume that the force is in between, is midway through the thickness, and then I have 4 of these. And if you do that, I wrote a little Excel file for that. I created a little Excel file for that, and I got 1.397 e to the power of 6 Newton meters, or 10 to the power of 6. Okay, so let's apply that moment. So I'll go back here, and I'll say loads moment, And I don't have the correct face, so I'll come back here and I will select that face. Okay, so the moment is being applied to this face. And instead of vector, I will say components. And I want to specify along Z. It comes out to be that value, 1.397 e to the power 6 Newton meters. Okay, and the way ANSYS applies that moment is if I come here and manipulate the view. Okay, so what it'll do is it will put forces at the nodes. So it'll put a force like that, and it has that moment arm, so you have a little moment from that force, and similarly at all the nodes. So if I have a force like that, and essentially, and the normal force will be 0 because that doesn't contribute to the moment. And essentially what that is doing is, if you think in terms of the boundary conditions on the boundary value problem, that's setting the normal stress to 0 underneath the hood. So you're specifying sigma ZZ equal to 0. Z is out of the plane of this face. And sigma XZ, or ZX, is some specified value, and sigma YZ equal to some specified value. And this will vary along that cross section. So that's what you're doing. And so to remind ourselves of that, because I see students getting confused about this, I will say moment, but what it's going to do is it sets stress components on that face. Okay, and I'll save file, save project.